My name's Eric Hansen. I work out of the horticulture department at Michigan State University, and I'd like to tell you about a new project we've initiated. In 2009, the Michigan Ag Experiment Station gave us startup money to construct 1 acre of high tunnels on the MSU campus. So this is in association with the MSU Student Organic Farm. And the intent of these is to provide a research site to test organic production practices for a perennial crop. So we'll start with raspberries, also sweet cherries, even nursery apple trees, and probably other crops. So they were constructed in 2009 and 2010 with support from the Ag Experiment Station here at Michigan State, as well as the Cirrus Trust and federal money. So for this project, we chose to use multi-bay tunnels, and these were manufactured by a company in England called Haygrove Tunnels Limited. And they're multi-bay tunnels. These are generally less expensive to construct than standalone tunnels. The downside of multi-bay tunnels in cold areas is that they don't support the weight of snow. So if you're in a snow-prone area, these type of tunnels need to be uncovered during the winter so they're not damaged by snow. So what we would like to do in this video is to show you the steps involved in constructing the tunnels. They're based on the manufacturer's directions. We are not construction experts. These were the first tunnels we constructed. This video should give you a general idea of the process and our experiences, but it's by no means meant to replace the recommendations and the directions from the manufacturer. In the future, we hope to use these tunnels for a number of different practices. So the first step in designing a high tunnel site would be siting. We chose to place these tunnels on a north to south orientation based on the space available to us. Then we laid out the rows. Our tunnels are 26 foot wide, so the leg rows are 26 feet apart, and we made sure, of course, to true up the corners to 90 degrees. Once the end rows are marked, we laid down a strip of weed barrier fabric between the rows. So this fabric is not essential, but we have learned that it makes weed control within the leg row much easier, and it also protects the soil from the large quantities of water that will be shed off the edges of the plastic in the future. Once the fabric is laid down, we measured out and marked with spray paint the points where the leg posts would go. We then cut a short slit into the fabric to accommodate the installation of the legs. Legs were placed next to each row, and then they were augured into the desired depth. The legs came with a mark at 30 inches, which is the depth they were installed to. And we used a skid steer and a hydraulic drill to auger these posts in, but you can also use handheld augers. We watched the legs from both sides to make sure that they were installed vertically. Once a few leg posts are installed, you can more easily sight the remaining legs against the first legs that were installed. The hoops for these tunnels are shipped as straight pipe, and that pipe is bent on site by the manufacturer. bent hoops were then carried to the tunnels with a tractor and forklift. And this was driven right down between the leg rows. Two people then lifted the hoops from the forklift and placed them on the forks. We found that it was easier to place one side of the hoop on one fork while the other end of the hoop was held very low. Then raise the opposite end of the hoop and place that on the other leg. Once the hoops were in place, they were secured to the leg post with Tek screws. The last 3 hoops on each end of each tunnel received additional bracing, so 2 struts were attached diagonally between the first and second leg posts, and 1 strut was attached diagonally between the second and third posts. We found it was much easier to put these struts in place with the brackets and then tighten all the brackets and bolts once the struts were in place. An additional brace was installed at the top of the tunnel between the first and second hoops. It was somewhat difficult to position this brace exactly at the peak of the tunnel, but this was not essential. Each hoop was then connected to the next at the peak. End anchors were installed next. These are placed outside of every second leg on the outside rows of the tunnel only. They were augured in as the leg rows were augured in, and then the 3 closest leg posts were wired to each of these anchors. So this was to protect against strong winds. Reinforcing wire was also installed in the center of each tunnel in a star configuration. This provided additional strength. The side bracing wire was run along each leg row and connected to each leg just below the fork. A second wire was run the length of each tunnel and was attached to each hoop a few inches below the bottom. So these wires provided additional strength. Once the structure and wire were installed, the tunnels were ready for covering or skinning with a sheet of polyethylene plastic film. The first step here was to place the poly roll on a pipe or a pole that would serve as a spindle. The poly sheet was pulled off the roll and laid in the troughs between 2 adjacent tunnels. We pulled the lengths of poly off by hand, but you can also attach a rope and tractor to this poly and make this process a little bit easier. We laid 2 lengths of poly in the same trough, and those pieces of poly were put on the 2 adjacent tunnels. To install the poly on top of the tunnels, it's critical to wait for nearly windless conditions. So in Michigan, this normally occurs early in the morning. We found that a minimum of 6 to 8 people are needed to skin the tunnels. The first step is to push a bundle of poly to the top of the hoops. Then unfold the poly at one end of the tunnel, pull the edges down to the trough, and be sure that the open sheet is centered on top of the hoops. Be careful not to rip the plastic with your hands. The poly is secured to the end hoop with pipe clamps, using a piece of thick fabric strapping between the poly and the pipe clamp. Once the poly is secured to the end hoop, the edges are pulled down to the trough on each side of the tunnel, working from the secured end to the far end of the tunnel. To pull the slack from the poly, workers on opposite sides of the tunnel can work together to billow and the poly up and down while pulling the excess poly down and towards the far end. Try to get the plastic as tight as you can. The poly is attached to the end hoop on the far end of the tunnel in the similar manner as the first end. The poly is secured in place with roping. This needs to be done immediately so that wind does not blow the plastic off the tunnels. The ropes are secured to the to the leg posts and pulled back and forth across the top of the tunnel. These are first hand tightened and can later be retightened with a pulling device.
I still want to rip a pool. Okay, so just a second. Okay, you can start pulling it back.
We are very excited about the opportunities to research organic production practices in these tunnels, and we hope in the future to develop additional videos to keep you informed of the progress on this program.